Good morning, friends, and welcome to another class. In today's episode, we will be looking at amount of substance and Avogadro's constant. Avogadro's constant is also called Avogadro's number. So remember, the amount of substance is usually mole. So what we'll do is we'll first define mole, then I'll explain the concept of mole. So let's define mole. Mole simply refers to the amount substance that contains as many particles as there are carbon atoms in 12 grams of carbon 12. So that's what the definition of mole is. The amount of substance that contains as many particles as there are carbon atoms in 12 grams of carbon 12. So I would have to explain this. What this is simply saying is this. So let me just use this to explain this. Anytime you have 1 mole of carbon 12, the quantity of substance in it is the same as when you have 1 mole of any other substance. So here, let's take a substance like 1 mole of iron. Let's take another substance, 1 mole of calcium. Now, the quantity of substance in or the particles in 1 mole of each of these substances is the same. So the actual value of this particle is actually 6.02 times 10 exponent 23, which we call the Avogadro's constant or the Avogadro's number. So for 1 mole of iron, you would have the same quantity of particles, 6.02 times 10 exponent 23. For 1 mole of calcium, you still have the same quantity, the Avogadro's number, 6.02 times 10 exponent 23. So it's an important concept you need to grasp. What it means is that if 1 mole of a substance contains this quantity of particles, 2 moles of that substance will contain this times 2. 3 moles will contain the same Avogadro's number times 3. As simple as that. Now, let's see if we can come up with the formula to illustrate whatever we've learned. Now, so for every substance, if you want to determine the quantity of or the number of particles in it, let's represent it by n. For you to get the number of particles in this substance, it's always equal to the number of moles. I'll represent mole by small n times the Avogadro's number. This formula is very important. So if you are asked to determine the number of particles in any substance, all you need to do is to multiply the Avogadro's number. Sorry, here the number of moles of that number. So it's this mole by the Avogadro's number. So the mole multiplied by the Avogadro's number would always give you the number of particles in that substance. And please, when I say particles, particles can be either ions, they can be atoms, they can even be molecules. So you need to remember this. So if you are asked to determine the number of, let's say, ions in, let's say, a particular mole of a substance, all you do is to multiply the number of mole by the Avogadro's number. If you have to calculate the number of atoms, you do the same thing. The number of mole by the Avogadro's number. What about, so this equation can also be manipulated. Assuming you have the number of particles in a substance, and you also, of course, the Avogadro's number will always be given to you, and you have to calculate the number of moles. All you do is to do change of subjects. So the number of moles would always be equals to the number of particles divided by the Avogadro's number. So this formula you also need to put into your head. Honestly, you do not need to put the second formula into your head. All you need to do is to put the first formula into your head and use simple basic concept in mathematics to do change of subject. Then you can always derive the second formula and determine the number of moles. So we're going to do some calculations, but remember that anytime you are given the number of moles of a substance, of course, the Avogadro's number would always be given to you, and you are asked to determine the number of particles. It could be ions, it could be atoms, it could be molecules of a particular substance. Always multiply the moles by the Avogadro's number. So this and this. So that's the first thing. The second thing is that anytime you are given the number of particles in a substance and you are asked to determine the number of moles, just take the number of particles given to you and divide it by the Avogadro's number. It's as simple as that. So let's see if we can solve some problems. So let's move to the first problem. So here we have been asked to determine moles of calcium carbonate that contains these molecules of calcium carbonate. So here we asked to determine mole, and you and I know that for you to get the mole, all you need to do is to divide the number of particles given to you by the Avogadro's number. So that's what we're going to do. The number of particles given to us, here the number of molecules is this number. The Avogadro's number, it would always be given to you. So I'll write it. So here that will be the number of particles will be 12.04 times 10 exponent 23 divided by the Avogadro's number, which would always be given to you. It is 6.02 times 10 exponent 23. So when you solve this math, 12 point uh what is that, 12.04 divided by this, what are you going to get? You're going to get 2 moles. So the answer is 2 moles. Remember, you were asked to determine the moles of calcium carbonate that contains this quantity, 12.04 times 10 exponent 23 molecules of calcium carbonate. So it will be 2 moles of the calcium carbonate. Very simple. Let's look at another example. So in this example, you were asked to determine the number of chlorine molecules in this mole, 0.5 moles. So here we've been given the number of moles to be 0.5. Of course, the Avogadro's number then would always be given to you 6.02 times 10 exponent 23. So how do we determine the number of chlorine molecules? That's the number of particles. That is the capital N. It is always equals to the number of moles multiplied by the Avogadro's number, which is L, which will give us 0.5 moles times 6.02 times 10 exponent 23. When you do the math, you're going to get 3.01 times 10 exponent 23 particles. So here to be molecules. Remember, the particles can either be molecules, they can be ions, they can be atoms. But here they say you should determine the number of molecules, chlorine molecules. So you would have 3.01 times 10 exponent 23 chlorine molecules. Let's look at the next example. So here, how many moles of potassium chloride contain these molecules? So you'll be asked to determine the mole by you've been given the number of particles. So the number of particles N is 18.06 times 10 exponent 23. That has been given to you. But we know the Avogadro's number is 6.02 times 10 exponent 23. So if you want the number of moles, which is small n, that will give us what? N divided by the Avogadro's number, which is equals to 18.06 times 10 exponent 23 divided by 6.02 times 10 exponent 23. When you do the math, what will you get? So you have this, so that will give us 3. So that will give us 3 moles. Remember, 3 moles of what? Of the potassium chloride. So that is the answer. So let's move on to the next question. The next question, if you asked to calculate the number of particles in 2 moles of helium. So how many moles have been given to you? You've been given number of moles to be 2. The Avogadro's number would always be given to you. It is L and it is 6.02 times 10 exponent 23. So to calculate the number of particles, it is capital N, which is equals to small n, the mole, times the Avogadro's number. And that will give us 2 times 6.02 times 10 exponent 23. When you solve the mass, 2 times 6.02 times 10 exponent 23 will give us what? To give us, let me just use my calculator. So that will give us 12.04 times 10 exponent 23. So that will be the answer. So 23 what? So that will give us particles. So this number of particles can be found in 2 moles of helium. Let's look at another example. In the next example, you will be asked to calculate the number of atoms in this moles or 1.5 moles of calcium. So the number of moles that have been given to you is 1.5. Avogadro's number would always be given to you 6.02 times 10 exponent 23. So if you want what? The number of atoms, which is the number of particles, that will give us this one, capital N. It is equals to the mole times Avogadro's number. So that will give us 1.5 multiplied by the Avogadro's number. So 1.5 multiplied by the Avogadro's number, what would that give you? So just quickly do the maths. and you're going to get 9.03 times 10 exponent 23. So that will be what? Atoms. Remember, question asks number of atoms. So that will be, and that's the particles there. That will be 9.03 times 10 exponent 23 atoms. So let's look at the next example. The next example, if you have to calculate the number of sulfur ions in 0.7 moles of sulfur negative 2. The number of moles given to us is what? 0.7. Avogadro's number will always be given to us, and it is 6.02 times 10 exponent 23. So if you are looking for the number of sulfur ions, which is the particle, that will be N equals to the mole times Avogadro's number, which will give us what? Will give us 0.7, all right? Then times the 6.02 times 10 exponent 23. When you solve the math, 0.7 times that give us 4.214 times 10 exponent what? 23. Remember, it said ions, so the answer will be ions. Those are the particles, ion particles. Let's look at another example. So the next example, we have to calculate how many molecules of uh, ammonia are present in this mole. So the number of moles given to us is 1.5 moles. The Avogadro's constant is always 6.02 times 10 exponent 23. This has already been given to you, all right? All you do is to determine the number of particles present here, molecules present. It will be capital N equals to the number of moles times the Avogadro's constant, which is equals to 1.5 times 6.02 times 10 exponent 23. When you do the math, 1.5 times that, that will give you what? Give you 9.03 times 10 exponent 23. 23 what? Remember how many molecules? So that will be molecules. Let's look at another example. So in the next example, you have how many moles of ion contain this particle. So here you are being asked to calculate the number of moles, but you've been given the particles to be, which is N, to be 10.836 times 10 exponent 23. Avogadro's number we know is what? Is 6.02 times 10 exponent 23. So to determine small n, which is the number of moles, equals to the big N, the number of particles divided by the Avogadro's number. So that will give us 10.836 times 10 exponent 23, all divided by 6.02 times 10 exponent 23. When you solve the math, what are you going to get? So that will give us 1.8 moles of what? Of the ion ion. So you need, that's the answer. It is this moles of the ion. Let's look at another example. So here in this example, you've been asked to calculate how many moles of carbon are in this particle. So you've been given the number of particles, this one, to be 3.01 times 10 exponent 23. Avogadro's number is always 6. It's constant. It's always 6.02 times 10 exponent 23. So that's what you're going to use for your calculation. If you have to calculate moles, the moles will be equals to the number of particles divided by the Avogadro's constant, which is equals to number of particles is 3.01 times 10 exponent 23, all divided by the Avogadro's constant, which is 6.02 times 10 exponent 23. When you do the math, you are going to get 0.5 moles of what? Of the carbon. So that's as simple as that. And I believe that will bring us to the end of our lesson for today. So the trick is this. Anytime you are asked to determine the number of particles, all you do is to multiply the number of moles by the Avogadro's number. And please remember, the number of particles can be number of atoms, number of molecules, or number of even ions. Now, again, when you ask to determine the mole, all you need to do is to determine the number of particles, the big N, by the Avogadro's constant. So you divide the number of moles, sorry, the number of particles by the Avogadro's constant, and that should solve your problem. As simple as that. We'll bring the lesson to an end. But please share the video if you've not done that, and subscribe to the channel if you've also not done that. We'll meet again in the next lesson. See you and take good care of yourselves.